Okay, so I'm also going to be explaining how to do an equilibrium expression. Essentially, what this is to show you like how something is like in a system is written as like when it hit equilibrium, this is what the equilibrium number is basically. Let's do it's hard to explain, so let's do an example first. So what we always should know is it's going to be K um Kc for molarity and Kp for pressure. So each one of these are written different. So I'm just going to do this problem, but in each. So what we're going to do is we should always know it's going to be products over reactants. Okay. So when you work with concentration, which is this one, it's always going to be brackets surrounding like any element. And for pressure, it's always going to be the big P and then the reactants. So now we analyze the equation. So there's N2, 3H2, 2NH3. Since there is a coefficient or the number of moles that is surrounded over here or before the element, that means you're going to be doing whatever this element is to that power. So this would be 3H2 cubed, and this would be NH3 squared. So I'm going to be writing this out as an equation. So I'm just gonna do this really quick. You see how this is the same thing that is the outline for this. So now you have this, and now if you want to do like a bicycle problem or whatever kind of problem that they ask you to, this would be your setup for concentration. So this will be your setup for any problem that they ask you to about equilibrium for concentration. And this would be your setup. Anything that you want to put in T here that corresponds with with whatever the product or the reactants, whatever it is you want to find, you can using this as your outline. Now I'm going to be doing KP. One thing you want to remember is that you're not multiplying these, you're going to be adding them. So I know it's like sometimes hard to forget, but you're just going to be adding them. You're not going to be multiplying them. And it confused me at first, but that's just how it is.